Hello everyone. Today we'll be revising the chapter of pair of linear equations in two variables. This is the first session for it. If you've seen the sample paper from CBSE for the standard paper for 2021, there are 7 marks questions that are there from this chapter. There are 2 questions of 1 mark each, and there is 1 question of 5 marks each. So let us just go through the chapter once. So let us see what are linear equations in two variables. We all know that the equation which can be put in the form ax plus by plus c is equal to 0, where a, b and c are real numbers and a and b are both not 0 is called a linear equation in two variables x and y. And also we know that each solution xy of this linear equation in two variables corresponds to a point on the line representing the equation and vice versa. Whenever we have an equation, and we plot it on a graph, every point on the line representing this equation is a solution of this equation, and every solution of this equation will be lying on the line that will be representing this equation. Let us consider two equations. Y is equal to 2x and 3x plus 4y equal to 20. So these two equations are in same variable x and y. Equations like these are called a pair of linear equations in two variables or a system of linear equations. So we can say that the general form of the linear equation is a1x plus b1y plus c1 equal to 0, and the second equation a2x plus b2y plus c2 is equal to 0. These two form pair of linear equations, and the condition is that a1 square plus b1 square is not equal to 0 and a2 square plus b2 square is also not equal to 0. So you all know few examples. We've done it in class 9 and we did it in class 10th also. That if I have a linear equation, I can draw a table, I can find out the solutions, put them in table and plot those points. And in joining the points which are satisfying the equation, I'll be getting a straight line. So whenever I have two straight lines on a plane, there are only three possibilities. One, that the two lines will intersect at one point like this, or the two lines will not intersect, that they are parallel to each other, or third, that the two lines will be coincident like this. So one way is that if I have a set of equations, I draw the lines representing those equations and I can see how will the graph be. It can be either intersecting or coincident or parallel. But my dear children, drawing of the graphs is not the only method of determining the graphical representation of the given system of linear equations. Even without drawing the graphs, I can find out whether the lines will intersect or they'll coincide or they'll be parallel. So just have a close look at the equations and their coefficients and the relation between the coefficients. For example, let us take these two equations. My first equation is x minus 2y equal to 0 and the second equation is 3x plus 4y equal to 20. Now, if I compare it to the general system of equations, the general system of equations is given by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So if I take these two equations and compare it with the general form of equations, then I can say that a1 is equal to 1, b1 is equal to minus 2, c1 is equal to 0. And if I take this equation and I compare it to a2x plus b2y plus c2 equal to 0, I get a2 equal to 3, b2 equal to 4, and c2 will come out to be minus 20. So now I find out the ratio of a1 and a2. I also find out the ratio of b1 and b2, and I also find out the ratio of c1 and c2. So a1 and upon a2 comes out to be 1 upon 3. b1 upon b2 comes out to be minus 2 upon 4, which is equal to minus 1 upon 2. So here a1 upon a2 is not equal to b1 upon b2. So we can say that whenever the lines will intersect, always we will have that a1 upon a2 will not be equal to b1 upon b2. Or conversely, if in case a1 upon a2 is coming not equal to b1 upon b2, for sure the graphical representation of the lines will be intersecting lines. The lines will intersect at one point and that one point will be the common solution, and so we'll be having one solution or a unique solution, we can say. So we can say that the graph of the system of equations with a1 upon a2 is not equal to b1 upon b2 would represent the intersecting lines. Let us come to the second case. Now you're seeing this graph. This graph is representing two sets of lines, one 2x plus 3y equal to 9 and the second 4x plus 6y equal to 18. So these are the two equations, the graph of which have been drawn, and I'm seeing that the graph drawn is only one line, or I can say that both of these equations are representing the same line, or we can say that we are having coincident lines representing these two equations. Now once again, let us compare them to the general form of equations and find out what are A1, B1 and C1 and what are A2, B2 and C2. If I compare, A1 is coming out to be as 2, B1 if I compare to this is 3, C1 I can take this 9 to this side to find out to make the equation the form of A1x plus B1y plus C1 is equal to 0. So I get C1 comes out to be minus 9. Exactly same way, A2 will be equal to 4, B2 will be equal to 6 and C2 will be equal to minus 18. So I have got these values. Now let us find out the ratio of the coefficients. Let us find out A1 upon A2. What is that? A1 upon A2 comes out to be 2 upon 4, which is equal to 1 upon 2. B1 upon B2 is 3 upon 6, which is equal to 1 upon 2. Let us find out C1 upon C2. C1 upon C2 is minus 9 upon minus 18. That means C1 upon C2 also comes out to be minus 9 upon minus 18, which is equal to 1 upon 2. So if I compare the ratios A1 upon A2, B1 upon B2, C1 upon C2, all three of them are coming out to be equal. So does it make you understand that if in case A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, I will get the lines will coincide. So the condition for the lines to coincide is that A1 upon A2 should be equal to B1 upon B2, should be equal to C1 upon C2. And I get that if A1 upon A2 equal to B1 upon B2 is equal to C1 upon C2 is true, then the graph for the same represents the coinciding lines. What does the coinciding lines means? That all solutions of this first equation will be the solution for the second equation also. That means the common solution will be all the points lying on this line or all the points lying on the other line which are coincidentally same. So that means that in this case we'll have infinitely many solutions. Let us see the third case. The system of equations given by the graph wherein the lines are now parallel to each other. So whenever the lines are parallel, let us find out what is the relation between A1 upon A2, B1 upon B2 and C1 upon C2. I have two equations given by x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. And I know the method of drawing the lines representing these two equations and I draw them and I find them parallel. Now let us compare these two equations with the general form of equations given by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So I get a1 will be equal to 1, b1 will be equal to 2 and c1 will be equal to minus 4. Exactly same way, a2 will be equal to 2, b2 the coefficient of y will be equal to 4 and c2 will be equal to minus 12. What is a1 upon a2? Clearly, A1 upon A2 comes out to be 1 upon 2. What about B1 upon B2? B1 upon B2 is 2 upon 4, which is also equal to 1 upon 2. Let us see if C1 upon C2 is also equal to A1 upon A2 and B1 upon B2. C1 upon C2 comes out to be minus 4 upon minus 12, which is equal to 1 upon 3. So we have here A1 upon A2 is equal to B1 upon B2, but it is not equal to C1 upon C2. So I can say that whenever I will have A1 upon A2 equal to B1 upon B2 but not equal to C1 upon C2, then the graphical representation of the equations will be the two parallel lines. Two parallel lines means they are not intersecting at any point. There is no common solution. So I say that there is no solution to these equations. Let us talk about consistency and inconsistency of the system of linear equations in two variables. Consistency means what? That the solutions will exist. So which were the two cases where the solutions exist? Wherever the lines are intersecting, maybe at one point or at infinite points, the equations will have solutions. If they're intersecting at one point, means that there will be only one solution. If they're intersecting at infinite points, means that they are coincident. We'll be having infinite solutions.
But in case the lines are parallel, means that they are not meeting at any point, so we can say that there is no solution. And when there is no solution, means that will be the case of inconsistent system of equations. So keep that in mind, please. So let us take up the previous cases once again with respect to the consistency and inconsistency. The first case, when the lines are intersecting, you can see that both the lines are meeting at a particular point, and this point is 4, 2. So I say that there is a unique solution given by 4, 2, and because this one solution exists, I say that this system is consistent.
So in this case, a1 upon a2 is equal to what? 1 upon 3. b1 upon b2 is minus 2 upon 4, which is minus 1 upon 2. So a1 upon a2 is not equal to b1 upon b2. So whenever I will have a1 upon a2 is not equal to b1 upon b2, I will have a unique solution. If you take this set of equations here, if I try to draw the graphs of these equations, I will find that the lines are coinciding. Now, coinciding means that there are infinitely many solutions. They are intersecting at infinitely many points.
So in this case also, because there are infinitely many solutions, therefore we'll say that the system is consistent.
a1 upon a2 is 2 upon 4, which is 1 upon 2. b1 upon b2 is 3 upon 6, which is equal to 1 upon 2. So c1 upon c2 also comes out to be 1 upon 2. So I get whenever a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, in that case, I get the lines are coinciding, and I say that the system is consistent and there are infinitely many solutions. Another important word for this is that the equations are dependent. If I multiply this first equation by 2, I will get the second equation or not? So whenever I can get the second equation from the first, the second equation is depending on the first, I say that the system is dependent. This is one word which children generally miss out. So both the equations will have the common solution set. And how many solutions will be there? There will be infinitely many solutions. And because the solutions exist, we say that the system is consistent. But the case where there is no solution, you remember the case of parallel lines where they are not meeting, that means there is no common solution. So whenever there is no common solution, we say that it is inconsistent. Thus, a system of equations is said to be consistent if it has a unique solution or infinitely many solutions. And graphical representation of a consistent system is either co-intersecting lines or coinciding lines. So let us take the third case. I have these two equations given to me. If I draw the graphs for these equations, I see that the lines are parallel, means there is no common solution. And whenever there is no common solution, they are not intersecting, means that the system is inconsistent. So if you remember the condition, here again, a1 upon a2 is 1 upon 2, b1 upon b2 is 2 upon 4, which is 1 upon 2, but c1 upon c2 is minus 4 upon minus 12, which is equal to 1 upon 3. So as I told you, a1 upon a2 is coming equal to b1 upon b2, but it is not coming equal to c1 upon c2. So let us revise everything through a table. If in case I have a1 upon a2 is not equal to b1 upon b2, I'd be getting intersecting lines. There will be only one solution, or we can say a unique solution. The system will be consistent and it will be independent. In case a1 upon a2 is equal to b1 upon b2, which is equal to c1 upon c2, I will get coincident lines. There will be infinitely many solutions. It will be a consistent system of equations. And because from the first equation I can derive the second one also, I can say that it is dependent. In the third case, a1 upon a2 is equal to b1 upon b2, but it is not equal to c1 upon c2. I'll get parallel lines. There will be no solution. The system will be inconsistent, or it will be independent, I can say. Now, keep in mind that this table is very important. If I say a 1-mark question, there are 2 1-mark questions that can come from this chapter. Most probably, one question will be surely there, which will be using any one of these conditions. So please ensure that you understand this table very carefully. So I hope the conditions for consistency, the conditions for unique solution or infinitely many solutions or no solution, or the system being dependent or independent, everything is going to be clear to you. Thank you so much.